انا راح اعمل ريكورد من عندي من هون على يوتيوب، ما في مشكله. اوكي. سوري حبيبي، ايش هيا؟ الشاشه عندك صغيره، اذا بتقلبيها ممكن تكون اه. ايش ينال، ايش تعمل؟ اه صح، تكبر صح. واخيرا شكرا يا حبيبي، شكرا. طيب آه. عمر انت معنا حبيبي؟ اوكي. هلا مس مريانا مي جوين، نشوف مش عارف صراحة اذا انها she is asking to join ولا لا. اوكي خلونا نبدا ان شاء الله. Okay, today our lesson is a little bit big. ف بدنا نحاول نشوف. اوكي ليش هيك في صوت؟ انا عملت ميوت. اوضح؟ اوكي احضر على يوتيوب وخلي هاد شغال عشان آه، خلي هاد شغال عشان اسمعك اذا بدك اشي. هاي يوتيوب شغال انا، اوكي؟ يوتيوب اونلاين لايف بالضبط ولا في ديلي؟ اوكي طيب خلينا نبدا. today زي ما اتفقنا today is Wednesday 18th of March 2020. Today we want to talk about age and fate of universe. We want to talk about when the universe has been created and what is the end of the universe would be. What is the death of the universe? You can find everything in pages 192 to 199. It's long. We can't finish it today. فأنا عملت part 1 ورح نعمل part 2 إن شاء الله، إلا إذا زبط معنا الأمور we may finish it today إن شاء الله. خلينا نشوف شو بصير. First of all عنا رح نحكي اليوم عن Doppler effect. Doppler effect is one of the topics that was included in AS and moved to A2. فهلا so far يعني راح يكون مطلوب منا Doppler effect. What does Doppler effect says that؟ بنقول there خلينا نحكيها بهذه الطريقة. استنى شوي. نقول the received frequency, or we may write the received wavelength. So it depends. We can say received frequency or received wavelength. Received frequency or received wavelength بنقول changes as there is a relative velocity between the source and the receiver. What do we mean by this? Let me explain to you. First, if we are sitting here and we hear an ambulance moving in the street, we can tell the ambulance is coming closer to us or going away from us. And the reason of this is because Doppler effect. We don't know this. Our mind just make use of this sound بس بالحقيقة the question is why the sound differs. Why when the ambulance is far away, there is certain sound, there is certain frequency or certain wavelength, and it's coming closer, the received frequency or the received wavelength will be different, will be changed than the emitted one. So there is a change in the received frequency. Anywhere you can write frequency or wavelength. There is a difference between the received frequency and the emitted one. يعني as a driver, هلا if I am the driver of an ambulance, I am driving going to a patient. While I am going, I will hear the sound of the siren all the time the same way. بس وانت قاعد في بيتك, while you are sitting here, if you hear the sound, you can tell ايه في شيء عم بيجي, كيف تعرف؟ لأنه the sound received by you is different than the sound emitted from the siren itself. And this difference is because of the relative velocity between the source and the receiver. What do you mean by the word relative? Relative means I am at certain speed and the source, which is the ambulance, is at a different speed. These two speeds, they are different. So the difference between them will make this difference in the frequency. What do I mean by this? I mean, let's say, لا سمح الله, the ambulance came to my house and I have here emergency. I asked them to come to my house to take, let's say, my kid. He's in need for emergency room. فاجت الambulance. While the ambulance is coming to our building, I can tell هي عم بتقرب. If they miss our building وخربطوا في الشارع وراحوا على الشارع الثاني بقول they are going away. بس imagine that وصلوا بيتي, they took my kid, الله يحمي الكل, they took my kid وبعدين I decided to go with them بس using my car. So I am driving after the ambulance. The ambulance is moving, I am moving in the same speed. So relatively, there is no speed between us because it's moving by the same speed, so I will hear the same sound all the time. If it was faster than me, then there is a relative speed, and then what I will hear will be different than what the driver أو حتى what my kid will hear, and it will be different. Clear هاي الجملة? Is it clear? أعطوني بس feedback عشان أكون متأكد. Is it clear يا جماعة؟ اوكي خليني بس اشوف هلا what will happen exactly? Will ايه بدك شيء هيا؟ Okay, now we want to know what will happen. Will the frequency increase or decrease? Listen to me. If here I have the ambulance, here is the driver, and it sends a sound. If it was at rest, then the sound emitted will be symmetric everywhere. If I have a receiver right here and I have a receiver right here, then both receivers will hear the same as what the driver is hearing. But if the car was moving toward one of the drivers, let's say this is driver, this is A, this is B, what will happen? Let me show you what will happen. This wave will be pushed because the car is moving like this, then the sound will be pushed toward this driver, so it will become, مش كان يصير like this. The other one, it's far from here and closer to here. Third one is much further and much closer. You can see this page. If my drawing was not very clear, you can see it on page 192. For this receiver, do you see here? the wavelength here is decreasing. Lambda is decreasing. While here, let me draw it this way. While here, lambda is increasing. So in case, if the car is going toward an observer, they are approaching each other. This is an important word. And even if the car is standing here, it's at rest here, and this man decide to come to it, برضو كمان, the waves that will be reached here, they will have a shorter wavelength. But here, it will have longer wavelength. If you are here, or let's say you are going away, even if you are at rest, the idea, in case of approaching or in case of receding, in case if you are coming closer to each other, or in case if you are going away from each other, then in these two cases, what will be emitted will be different than what will be heard. What will be heard by this one will be higher frequency, shorter wavelength. Higher frequency, shorter. What will be heard by this person is more wavelength, but less frequency. So, if this is clear, let me erase it and write this conclusion. You know, ايه صح. الحقيقه يعني هو هذا كان لازم يكون ب اس، هذا كله كنا ندرسه في اس. اجلوه ل 12 هبل بصراحه، بس هلا you will see where do we use this. اوكي اوكي بنقول in case of approaching, in case of approaching means source is coming toward the observer or observer toward source. Okay, they are coming closer to each other, source and observer أو receiver, خلينا let's call it، مش ضروري يكون he's watching something, maybe he's hearing something. Receiver are coming closer, then the received frequency will be higher than the emitted one. Okay? Or we may say the received wavelength will be shorter than the emitted one. Okay? Other in case of approaching. Now, if I want to change it to in case of مش approaching, in case of receding. Receding means the source or the receiver are going further apart, are going further apart. Then what will happen? Then the received frequency will be the opposite, will be instead of higher, will be shorter, will be lower than the emitted one, but the received wavelength will be longer than the emitted one. Is this clear? Okay. تتحملوني ثواني بس يا جماعة، خليني أشوف إذا بقدر خليني أبعت هنا اللينك. Is this a link? Yes. Copy. check هذا الويب سايت يعني بس برضه كمان ممكن تشوفينه. Okay. Well, then the receive frequency will be lower than. Okay, is this clear? Okay. Now, how much it will be increased or decreased? It depends on the received or the relative speed. How? Like this. The Doppler shift, they call it Z. هيسموه Doppler shift. Doppler change in frequency or Doppler change in the received frequency and the received wavelength is equal to the change in frequency over the original frequency, the one that is emitted originally from the source, or it's the change in the wavelength divided by the original wavelength, or it's the same as V over C. What does this represent? Z represents the Doppler shift. Doppler shift means the change in the wavelength. The Doppler shift, it's equal to delta F, how much the frequency has been changed, the change in frequency. F naught is the original frequency, I will add something here. So if you are writing with me, just leave a space here. Write with me delta lambda. Well, lambda is the change in the wavelength. Change in wavelength. Lambda 0 is the original wavelength. Now, what does V and what does C represent? V represents the speed of object. Speed of object. So, in my case, it will be the speed of the ambulance. In the example that I explained it to you, it will be the speed of the object. C is the speed of the wave. Speed of wave. Okay. Let's see what are the units. Change in frequency, hertz. The frequency, hertz. Change in wavelength, meters. Meters per second. So Doppler shift has no unit. Okay? Then, now let's go back to Yanel's question. شو دخل هذا الشغل كلياته? What is related to the how it's related to the speed of the to the universe with stars, all of this. Okay. Because I want to erase this, unfortunately my board is small. Let me write a statement here and then I will go back to it and explain it again. معلش تحملوني. نقول هون F0 is هون the wavelength 0 بنقول the way original wavelength or lambda in lab. And here 0 is F that is obtained in the lab. What does this mean? I will explain it best after. Give me just like a few seconds. Okay. مش عارف. Do you need any question so far? Yet? But do you have any question? ايش؟ Yeah, distance it will causes the relative speed to be different. يعني if the speed between me, if the distance between me and the car is the same, I am going and the car is going by the same speed, then the distance between us is the same. But if the distance is increasing, this means that the relative velocity is increasing. There will be bigger Doppler shift or bigger change in frequency or bigger change in wavelength. The idea, if there is constant distance, then there is no Doppler effect. If I am standing there and the ambulance is right there, I will hear the same sound all the time, even though كان different than the received one. بجوز لأنه يصير في fading out، لأنه يصير في absorption للenergy from the atmosphere ممكن. بس بغض النظر I can tell from it's coming to me ولا going away. I can tell it's at rest. كيف عرفت؟ حاسس انها at rest، ما عم تتحرك، نفس الصوت. فاهمين كيف؟ فالdistance affects whether you are increasing or going closer or away. هلا جاوبتك عمر؟ Is it clear right now? Okay. طيب. Now listen to me. هلا where is this related to the stars? In AS, we studied something we call it absorption line spectrum. Do you remember this? Absorption line spectrum. What was this? It was colored background. So you can see the red, orange, yellow, green, blue, indigo, violet, with only some dark lines, one here, one there, one here, one there. We don't care where they are. If you remember with me, you can see this on page 193. If you have your notebook, your text box, please open it just to see what I am saying. These lines, احنا اتفقنا انه they were matching the emission. If you remember the emission line spectrum, قلنا هو الopposite، هو بيكون dark background, all of this is black, nothing there, just only there is line here, red line, green, blue, and this is what we call it emission spectral line. We said, if you remember, these lines are result that certain element, certain element has been excited to higher energy level. Then as the electrons fall down to lower energy level, they will emit energy in forms of photon, and these photons will have certain wavelengths, so we see them at certain lines. We can use this line to tell what material exists in a certain sample. مش عارف ينال وهاي لانه مش انا درسكم AS قديش هذا كلير. اذا مش كلير اسالوني عشان اجاوب اكثر عن هذا emission spectral line. فاهمين ايش عم بحكي emission spectral line؟ What is it؟ ينال هيا اوضح اكثر ولا فاهمي شو اللي بحكي؟ اوكي جريت. طيب هدول emission spectral lines, absorption spectral lines, from where we get these absorption line spectrum, we receive them only from the sun, and we could tell إنه الsun فيها hydrogen وhelium. وقلنا there is a fusing between hydrogen and helium. طب كيف عرفتوا أستاذ؟ Did you get any sample from the sun وعملناها analysis to discover that it has hydrogen and helium? The answer no. Again, when we noticed these black lines and we compare them with the emission spectral lines of hydrogen and helium of all elements, we discovered that they are matching these lines for hydrogen and helium. So we discovered that the sun atmosphere must have hydrogen and helium there. بعدين قلنا طب شو بيعملوا هناك؟ We discovered they are fusing together, hydrogen is fusing with hydrogen, producing helium. Okay, هذا clear لهلا؟ هذا كله AS we need it. Clear يا جماعة؟ فاهمين؟ شكرا. طيب هلا when we try to do this in the lab يعني when we are trying to see what is the emission spectral line obtained in lab يعني we just do the same light as the sun, we put in front of it hydrogen and helium, we receive this spectral line. We are confirming انه هذا الاشي عن جد it's because of hydrogen and helium. Okay? When we do the same thing for any other star, مش احنا قلنا all stars are made from protostar and protostar is made of hydrogen and helium. So all stars, they must have the same spectral line, must be identical. Listen to this. We discovered that red, orange, yellow, green, blue, indigo, violet. We discovered that these lines are not exactly here. Not exactly. It has been shifted. This line has been shifted a little bit toward the red. And this one also shifted a little bit toward the red, but the same shift. This one, this one, this one. So if I try to see what will happen, I will discover that this line has been shifted this way, كلياتهم نفس الشفت, same shift. This is what we call it redshift. This is the emission spectrum. هذا lines received from a certain star. مش مهم ايش مكان يكون. From a certain star. So when we compare the absorption line spectrum received from a star compared with the one that we did it in the lab, we discover that these lines are not exactly matching the hydrogen and helium, لأنهم they are a little bit shifted to the right or to the red, واكتشفنا انهم كلهم the same shift. فهم we discover انه عن جد هدول lines represents hydrogen and helium, لكن the wavelength has been increased. What does this mean? Doppler told us if the wavelength increases, if the received wavelength is different than the original, this is what we received from star, this is what is obtained in the lab, this is the original one. If this is longer, then this means the star is moving away from us. From us means from Earth. Okay? طب أستاذ, do we have stars that these lines are shifted in the opposite way? Yes. And they call it blue shift. But listen to this fact. We discovered that majority of stars are showing a red shift. This is what we call it red shift. What do you mean by red shift? It means the received wavelength, the wavelength from the star, wavelength from star is bigger than the wavelength obtained in the lab. What does this mean? This means the star is moving away from us. Do we have the blue shift? Yes, we have the opposite. We call it blue shift. Blue shift. What does blue shift means? It means that the wavelength received from the star is shorter than the wavelength obtained in the lab. So this means the star is moving closer to Earth. Okay? This is what do we do right there. Right. يعني I believe that you can go back to this to photocopy it if you did not. بس خليني let me erase it. حملوني. Okay. نقول since this is a note, since most of the stars, majority of the stars are showing a red shift, then this means everything is going away from us. So this means the universe is expanding. The universe is expanding. طب أستاذ, do we have any blue shift? Very little. There is a blue shift, but it is very little. So this means the universe is expanding. Like, if the universe is expanding, this means in the past it was starting from one point and now it is expanding. So it started from Big Bang. So this is the theory that we use it to show that everything started from a Big Bang. إذن Doppler shows that majority of the stars has a red shift. What does this mean? It means the universe is moving away from each other. It is expanding. If it's expanding, then this means this means if it's expanding, then this means it is going away. If it's going away, then this means it has been started from a certain point. If it started from a certain point, then surely, if it started from a certain point, then surely it means it started from a Big Bang. And this, what do we want to say? خليكم بس شوي صغيرة معي عشان أقدر أشيل هذا يسيف. أوكي. ثواني تحملوني بس شوي صغيرة. Export to device. طيب. Now, remember with me, when we wrote Z equal C, V will be what? It will be the speed of the star. We call it speed of recession because it's going away. طبعا even if it was coming برضه equation هذا Z, it could be red shift or blue shift. I called it Doppler shift. C is the speed of what? احنا قلنا speed of the wave. Here it is light, so speed of light, which is 3 times 10 to the power of 8 meters per second. Okay. Okay. And Z is the Doppler shift. So if I give you what is Doppler shift, you can tell me easily how far is the object there. Okay. There is a word example on page 193. I want to do it just to make sure that everything is clear here. Page 193. It's already solved there, but let me read it for you. Good. In a laboratory, the hydrogen alpha spectral absorption line is at a wavelength of kaza nanometer. So this is 656.285 nano. In the spectrum from a nearby star, this is lambda received from a star. The same one is observed to be 656.3 315. طلعوا قديش الديفرنس؟ It's very little difference. 285 315. It's only in point of nanometer. It's very little difference. Yes, we don't expect the node to be that big. How far is the star is moving? Find the speed of the star. Okay. How far is the speed of the star? Find away. And I may ask you also command find Doppler shift. How do we find the speed of the star? If he wants Doppler shift, you'll Z equal V over C equal delta L over L. Oh, he doesn't want Z. If he wants Z, we can find it easily by finding this over this. V, this is what we want. C 3 times 10 to the power V divided by the original one is this one. 656.285 nanometer says it's okay. The difference here also in nano, they will cancel out. So no problem. So now this minus this. Big minus small. Always do big minus small. 0.315 minus 656.285. Now, so V equal these two multiplied by this one, the answer will be 13,700 meters per second. Now the question is it moving away or toward the earth? Somebody answers me. يلا. شو رأيكم؟ ينال. Is it going toward the earth or away from earth? يلا يا جماعة ساعدونا. ايش هي؟ away. كيف عرفت؟ لأنه الويف لينث. Yes, wavelength is increasing. So yes, it is going away. إذن هذا away from earth. طبعا you will find the answer in the book. It's written as 13.7 kilometer per second. Do we have these units? Yes, we have the speed. For stars, we use it in kilometer per second لأنه they are traveling at very fast speed. مش 1 meter per second ومش عارف قديش meter per second. It's in thousands kilometers in 1 second. So this is the speed of a star that's away from us. Is this clear so far? Is it clear? ايش هو حبيبي؟ The original wavelength is the one that we obtained in the lab. يعني احنا بنعرف انه الهيدروجين has a wavelength الريد لاين تبع الهيدروجين let's say هذا let's say من عقلي هذا I think انه هذا تبع الريد. ايوه يس هو اعطانا فهذا تبع الريد let's say 656.285. طيب تعال نطلع الريد تبع هذا الستار مش بالضبط هيك طلع 656.315. طب وهذا نفس الاليمنت هذا هيدروجين هذا هيدروجين هذا ريد هذا ريد. ليش يكون في ديفرنس؟ قالوا لانه the star is moving away. How much it's going away؟ هي السبيد طلعت 13.7 كيلومتر بير سكند. اوكي؟ اوكي. طيب في حدا عنده كمان استفسار؟ اكمل شرح؟ اوكي ممتاز. طيب هلا فذس از هلا بدكم كالكوليت دوبلر شيفت عادي هي تعملوا لو احسب زي تعمل this over this alone بدون ما تعمل times 10 to the power. I think انه هي احسبوا لي اياها بليز قديش بتطلع الدوبلر شيفت بيطلع رقم صغير ما بيطلع كبير. احسبوا لي اياها 0.030 over 656.285 بس هي الحالة قديش تطلع؟ هذا حسبها times 10 to the power -5. اوكي شايفين الزي لما اقول لكم احسبوها توقعوا تكون هالقد ايه يعني صغير يعني ما توقع تكون الجواب 2 3 لا تكون very small number. دائما اصغر من واحد اكيد لازم تكون اصغر من واحد لانه دائما the speed of the star much be smaller than speed of light وبالحقيقة أصغر بكتير بده يكون very short number يعني ما بيطلع big number we call small number okay طيب there is another evidence that the universe started from a big bang okay let's be okay no another evidence that the universe started from a big bang. It was بيسموها microwave background radiation. Is microwave background radiation, MBC. I think they write cosmic microwave background radiation. Even if you don't write the cosmic, it's okay. What does this tells us? Small. In 1963, I believe, in 1960s, there were two scientists, one American, one British. This is what I remember. Maybe it's not true 100%. This is what I remember when I read about it. They discovered that there is a microwave radiation in the environment around us, just like the background radiation تبع radioactivity. بس ذاك radioactivity we know that this is gamma. This is not microwave. اكتشفنا there is a background when it's received from the outer space. But from where this comes, بنقول these waves, they are formed in the Big Bang. And as the universe is expanding, then the temperature of the universe is cooling down, getting less and less and less. So this means احنا بنعرف انه lambda t equal to constant. So as this is decreases, this is increasing, and now it reaches to the very long wavelength, which is microwave. طبعا the longest هو الراديو ويف. فاحنا we expect انه هذول radiation يتحولوا لراديو ويف after some millions of years. يعني it will change to radio wave. In the past, it was not microwave. In the past, maybe it was gamma because it was very hot. When it's very hot, this was very short. So maybe it was gamma. Then it changes to X-ray. Then it changes. So if they ask you, explain how the microwave background radiation, the cosmic microwave background radiation, how they give evidence for the Big Bang, with all the microwave radiation. And another evidence that the universe started from is the microwave background radiation, which is originated in the Big Bang, and they come from the universe. So this means the universe is expanding. يعني خلينا let's هيك have a point of view here. احنا بنقول it is originated from the Big Bang. بس بالحقيقة احنا as believers, whether we are Christian or Muslims, we believe إنه God created everything. صح؟ in the Holy Bible it's written that in Genesis 1 verse 1 بيقول in the beginning God created everything. In 1963, when they discovered these microwaves, one of the scientists that was director of one of the important magazines in the universe talking about this, he decided to resign, and he said, "No way, I will not accept this discovery." And this is a discovery. He was an atheist. He does not believe in God. He said, then this means Genesis 1:1 will be true, and I don't believe in God, so it's impossible to be true. So there is nothing called microwave background. تخيلوا الأفكار ما لهاش دخل يعني في هذا بس imagine it in this way. Yes, there was a Big Bang, but the Big Bang did not happen by itself. We know the answer. God made the Big Bang. If it was a Big Bang, if it was not a Big Bang, whatever it is. That's yani, this is what is required from us here. So now, if I want to know what is the age of the universe, I need to know when the Big Bang has happened. Clear? How do we know when the Big Bang has has occurred? شوفوا جابوه لأن لو اسمه Hubble's law. What does Hubble's law states that? He discovered that the speed of recession of stars and galaxies is directly proportional to their distances from Earth. شو قصدك أستاذ؟ What do you mean by this? Wait a second, let me fill my ink. What does this mean? Hubble, he said, if I put here the distances between stars compared to Earth, or يعني distance between stars, between their distances from Earth. And here I put the speed of recession. Speed of recession. What do I discover? طلعوا يا جماعة. They discovered that when the star has this distance, let's say, its speed of recession was this much. And there is another far star, yesterday we were talking how do we measure the distances of stars. This far star has higher speed of recession, and so on, and so on. So when Hubble, when he tried just to plot all where the stars lie, he could draw the best fit of all stars, and the stars are on this line or away from this line, just like this one. Okay, but he just created the best fit, and he discovered that the speed of the stars is directly proportional to their distance. In math, we know that if it's directly proportional, then this means there is constant times d. This v, this is the speed of the star, the speed of recession. Recession yani going away, moving away. Speed of recession. Now k, this is a constant, they call it Hubble constant. And d is the distance of a star relative تبعنا هو Earth. يعني احنا we can't measure the distance from anywhere. احنا we measure it from Earth. فزي كأنه Earth is center of the universe, which is not, and they don't say this. بس هيك احنا, this is what do we do. How much is this constant? الحقيقة this constant has been changed widely. لأنه الstars that we are discovering كل يوم we are discovering more stars. لما كان هيك لاين كان هون في ستار هون في ستار هون في ستار after a little bit further after 10 years صار في هون more stars فهذا gradient صار هون بعدين more stars صار هون فهو بالحقيقة if this is V and this is D then the gradient of this is K مظبوط ف K is Hubble constant is the gradient and this has been adjusted many times بالكتاب حاطين عندنا table, you don't need to know to look at it if you want. It's on 196. It tells you at what date what was K. هلا بيقول nowadays value for K is 71. If I remember, it was 71 K. Okay. You don't need to memorize it. It will be given to you. K is how much? We discovered that K is equal to 71. 71 on what? Listen to me. إذا بترجعوا معي على هذا K equals speed over distance. مظبوط؟ But the unit of the 71, the unit, it was مش meters per second, kilometer per second. And the distance was not in meters, it was in megaparsecs, so mega PC minus 1. This is K. You don't need to memorize it, but they will ask you, for example, to change, find K in هو K ايش اللي تبعته اصلا K هو speed over distance meters per second over meters, so they cancel out, so it's per meter, okay? So they will ask you, change K, find K in per meter. Find K in second minus 1. No, K equal 71. The kilometer is 1,000 meters per second. Over, because it's per, it's already per. Mega 10 to the power of 6. البارسك امبارح كتبناه I don't remember it. Do you remember it? You have your note. Let me figure it out from the book. You don't need to remember it. بس البارسك is ما طلعتها. هي 3.09 times 10 to the power of 16 صح؟ 16. Okay. Would you do the calculation for me? No, it's not there. It's not in the book. For K equal 71 times 1,000 divided by, this is meters. So meter with meter will cancel out. We will answer second minus 1. And you find it for me. This divided by this. Okay. 2.29 times 10 to the power of negative 18 per second. Okay. Do you agree with هيا بلاش تطلع غلط؟ أنا I believe إنه صح بس يعني just in case. Okay. Now شو دخل هذا الأستاذ في age of universe? Listen to me. The age of universe is right here. The universe started from the Big Bang when there was no distance. And now the distances between the stars is this much. If we can't tell what is the time taken for this to come from here to here, will be the age of universe. So the age of universe is a time. Time is the distance over speed. Distance over speed. Which distance and which speed? ما هو ratio between them is constant. فبقدر اخذ 1 over Hubble's constant. But can you do it for us, please? Haya, 1 over your answer on the calculator. So what is the age of universe? Age of universe. 1 over this number 2 طبعا ما بصير تحطوها 1 over 71 لانه 71 كيلومتر per second unit what it will be هيك it will be in second times 10 to the power of negative 18 قديش هي طلع؟ 4.35 times 10 to the power seconds. But let's try to find it in years. Divide by 365 times 24 times 3,600. Yeah, divide by, open bracket, all of this number, please. أيوة. times 10 to the power of 10 years. هذه بيعملوها هيك بيعملوها 13.8 times 10 to the power of 9 years أو بيكتبوها 13.8 billion years. So this is the age of universe. And this is the number that if you Google it right now, you will find it around this number 13.7, 13.8, 14 هيك roughly. لأنه K is still changing. أنا عملته 71 هو بجوز 70.9 شيء زي هيك يعني. It's changing, but this is the age of universes. And assuming that the universe started from a Big Bang, then we can tell what is the age of universe. This is the age of universe. Interesting, صح؟ ها؟ الكي بتغير لانه بالحقيقه انا شرحت لك قلت لك الكي هو البيست فيت صح؟ البيست فيت هو represents what؟ هون عندنا سبيد هون عندنا distance. احنا we are discovering new stars. عندنا اليوم we saw this star has this is distance and this is speed. بعدين شفنا هاي الستار بعدين شفنا هاي الستار وصلنا البيست فيت طلع عليه. After 10 years we discover more stars here. فالبيست فيت بطل هيك صار هيك. فكي has been changed because the more the discovery of the stars would change. هلا so far we expect K to be constant, would not be changed الا اذا صار في عن جد big يعني خلينا نقول discovery ما كناش شايفينه من قبل. فso far this is the age of universe. ممكن يتغير يعني بعد فتره مش انه يتغير الايج اوف يونيفرس، لا يتغير الاستيميشن. احنا الاستيميشن تبعنا غلط. ايج اوف يونيفرس ما طلعش 13.8 طلع فرضا 14.8. ليش؟ لانه كي ما طلعت 71 طلعت less than 71 طلعت بس 69. ليش 69؟ لانه في عندنا more stars has been discovered ما كناش شايفينه من قبل. فاهمين كيف؟ فالاستيميشن يعني قبل بجوز مش عارف قديش بالتسعينات كي كان بال50 55. فكي لما كان صغير 50 something الايج كان اكبر بكثير. فاحنا كنا متوقعين انه الايج اوف يونيفرس بجوز كان بال 20 بليون يير ولا ابصر. ناس بصراحه قديش الارقام بس يعني big number. هلا شورتر. فهو الحقيقه الايج اوف يونيفرس is not changing بس our estimation for the age of universe is changing depending on what do we discover daily. Do you like what we're saying? What we are saying? Thumbs up يا جماعه. حلو؟ صعب؟ We may stop أو I want to start Fate of Universe. أنتوا شو شايفين؟ مناسب؟ Do you want me to continue? Fate of Universe؟ غير ينال عمر. طبعا ما هو مش بس theories وفيهم large uncertainty يا حبيبي. لأنه هذا كلياته يعني أنا بقول لك قبل 20 years كان الاستيميشن غير عن اليوم. احنا مش يعني احنا عارفين. انا مش زي كيف بقول لك انه متى صارت الحرب العالميه الثانيه خلاص معروف بال 1964. هذا نون هيستوري ما في مجال فيه للاستيميشن. هذا استيميشن طبعا وبيج استيميشن وتشينجينج استيميشن والuncertainty فيه عالي كتير. We can tell how much the uncertainty is there. Okay? Aslan, let me ask you, explain why there is big uncertainty in estimating the age of universe بنقول because it depends على K. Okay, depends على the distances of stars, and it's very difficult to find the distance of very far stars. يعني the distance estimate finding the distance of very far star has big uncertainty. فإذا determining D has big uncertainty, then determining K has very big uncertainty. And it depends على how, it depends على speed, both فيهم uncertainties. K is very uncertain or has big uncertainty. فأكيد the age of universe is only an estimate. It's not based on any خلينا نقول experiments ولا شيء. It's not. It's just only estimation. طيب. Now, the last thing, fate of universe. What is going to happen for the universe? ركزوا معي. Yeah. Fate of universe. Now we are sure that the universe is expanding. What would happen next? There are three possibilities. Either it will keep expanding forever, or it will expand to a certain limit and then stop expanding, or maybe it will expand to a limit and then it will shrink again. So there are three possibilities for the fate of the universe. There are three خلينا نقول scenarios. يعني احنا we don't know what will happen, but there are three possibilities for what will happen for the fate of the universe. First, it may keep expanding forever. In this case, we call it هذا بيسموه open universe. طيب, if you are writing with me, just keep a line here empty because I want to add another statement here. 2. Or it may expand up to a max size of volume, then it stops expanding. And such a universe, we call it flat universe. برضو كمان I want to keep a line here. The third possibility, it may expand up to a maximum size of volume, then it will collapse to بيسموه مش احنا قلنا في عندنا big bang، هاي بيسموها big crunch. It will crunch. This is, we call it closed universe. Okay, now pay attention. There are three scenarios. When this scenario may occur, it may طبعا على أي أساس بنقول it will keep expanding forever if there is no enough gravitational force to stop the expansion. When this occurs بنقول هذا it will occur if the density of the universe was smaller than certain density. We call it critical density. كيف critical angle? Same idea as the critical angle. and it will expand, then it will stop expanding and it will become flat universe. This will happen if the universe density was exactly equal to the critical density. And it will become close if density of universe was greater than the critical density. طيب. Now, Ustaz, how much the density of the universe? We don't know. How much is the critical density? We don't know. طب Ustaz, why we don't know? Listen to me. Listen to me. Now, we don't know what will happen to the fate of the universe, what will happen to the end of the universe, because we can't tell what is the density of the universe or what is the critical density. And the reason why we don't know what is the density of the universe or what is the critical density is because we don't know what is the mass of the universe. كيف أستاذ؟ الحقيقة احنا we know what is the mass of the universe. Do you understand me? We know what is the mass of the universe. احنا مش شايفين هدول stars? We calculated the mass of the universe. And since everything is in continuous motion, عشان هيك إذا بتحضروا على يوتيوب أي ستارز أو أي شيء للجالكسيز بتلاقوا في لهم spiral hands وبيكونوا عم بيعملوا هيك they are twisting, they are turning around each other. If you see how stars are rotating, then this means there is a centripetal force that produces this circular motion. But this centripetal force, خلينا نذكر من unit 4, and the centripetal force equals mv squared over r, right? If you put what is the mass of the universe that we already calculate it, then the centripetal force that will be calculated will be much smaller than what it should be. So the calculated mass of universe is much less than the real mass of the universe. Again, small. What do we know about the mass of universe is much less than the real mass of the universe. طب how come? اسمع شو قالوا. قالوا this means there is a dark matter, and I will write this, don't worry. There is a dark matter that has a huge mass, much more than the visible mass of the matter. So the mass of the matter is unknown. So the density of the universe is unknown. Then the critical density, we can decide what is the critical density. Then what will happen for the universe will keep an open-end question, and we can't tell what is going to happen to our universe. We don't know what will happen. We don't. What we know, it may, مش it will, it may. And I can tell you what will happen exactly if you can tell me what is the density of the universe. Because if I know what's the density of the universe, I can easily decide what is the critical density. The density of the universe depends on the mass of our volume. Mass of universe, the measured mass of universe is much less than the real mass or what it should be. But the estimated uncertainty is much less, for we don't know. Do you have a question before I erase? I want to write what I said. Do you have a question? هيا عندك شيء؟ قلنا اسمع الجملة اللي أنا حكيتها. ثواني أمحي هذا وأجاوبك هذا السؤال مرة ثانية. استنى شوي. Well, there are three possibilities. هذا here This is the size of universe, and this is the time. The universe started from time equals 0. This is the Big Bang. There are three possibilities. Either it will keep expanding forever, and this is what we call it open universe. Or it will expand up to a maximum value, then it will become flat. Or it will expand up to a maximum and then it will come to a big crunch, which we call it closed universe. Now, this is time. If you look, where is 13.8 billion years? You will find this is now. Now we are here. We don't know what will happen next. We may go to a big crunch, we may expand a little bit more and then stop, or we'll keep expanding forever. And we can't tell what will happen because the density of the universe, the found density of the universe is not realistic. We did not accept the calculated density of the universe. Why? Because when we try to find density of universe, we try to find what is the mass of universe over the volume of the universe. So now we took the mass of everything that's visible. This is the visible mass over the visible volume. This number was too small. It's impossible for the density of universe to be this small. Why? Because the mass, when they put it in the F equal mv squared over r to find what is the centripetal force that causes all of this motion, this number was not realistic. It was too little. Why? Because this, we use the visible mass. فهم الساينتست قالوا this means, okay, the mass of the universe is the mass of the visible matter plus the mass of the dark matter. How much the mass of the dark matter? We don't know. Why? Because the dark matter radiates undetectable radiations. يعني احنا في عندنا من جاما لا radio wave. Dark matter emits radiation beyond this limit. فاحنا مش عارفين قديش هو. Once we find a device that can measure the radiation received from the dark matter, we can tell what is the mass of the dark matter, then we can decide what is the density of the universe, then we can decide what is the critical density of the universe, then we can tell what will happen for the universe. Clear? Is it clear? I know that it's hard to hard to believe it, but this is it. في حدا, do you have a question يا جماعة? Okay. So, let me write here. So, the mass of the visible matter is very little, which means there is a dark matter that sends undetectable detectable radiations. So once we get a device that detects these radiations, and the problem is with our devices. If we get to receive these radiations, we can tell what is the mass of the dark matter after we know what is the mass of the dark matter. We can tell what's the total mass of the universe. Then we can tell what would be the fate of the universe right there. Okay. Do you have any question? Yanal, Haya, Omar, you have any question? Okay. If there is no question, we may say now we are done from 11B. Now we skipped 11A. We'll go back to 11A. What I ask you, please do the questions on page 202 and 203. 202 plus 203. Do the questions, the exam practice at the end of this chapter. We will solve them together, inshallah, tomorrow same time. Okay, tomorrow same time, and we will make a quiz or exam in astrophysics after we're done from 11A. And still we need to do 11A before we do the exam, لأنه everything is related to each other. فمعلش بدنا نتحمل, بس let's do this, please do 11B with me, and I will try to print out some questions for you and send it via the WhatsApp group so that you can practice a little bit more. But so far, let's do this, and tomorrow we will discuss it. Today, expect from me today some questions. I will send them by WhatsApp to your group. Okay? يعطيكم العافية. يلا. أهلا يا حبايبي.